All right, so we're getting set up to record some calorimetry today. So I thought I'd kind of talk you through the setup and show you some of the equipment so you know what to expect and what everything looks like. We have here the heart of the setup is our calorimeter. This is just two styrofoam cups nested in each other, and it doesn't look very fancy, but it actually does a pretty good job here because the main thing we want to do with the calorimeter is minimize the heat exchange with the environment. So when I put a couple of lids on here, it actually does a pretty good job of that on a short time scale. The styrofoam is not only pretty well insulating, but it's actually, if we put it on the balance here, you can see it's pretty low mass. The cup is only about 8 grams, and so that means if the cup heats up a little bit because of something hot in it, we lose a little bit of heat to the cup. It's not going to be very much because the mass is pretty small, so it doesn't take a lot of heat to heat up the styrofoam to be in equilibrium with whatever's in it. So that's our calorimeter. You saw the balance already. These are the thermometers I'm going to be using. These work pretty well for this because they're pretty low mass and they're very responsive. So I have them hooked up to this acquisition system on the computer. You can see if I hit record, I've got two of them, one for the sample that we're going to be recording the temperature of and one for the water. And you can see it's about 22, 23 degrees in here. But if I take this one for the water, this is the lower temperature one, you can see if I hold it between my fingers, that temperature starts going up pretty quickly. So these are nice, fast, responsive, low mass thermometers, so they work pretty well for this. This is the sample that we're going to be characterizing the specific heat of. So it's just a little slug of metal with a hook, and you can see I've got one of the thermometers taped on there with some high temperature tape, so we can get a good reading of the temperature of this thing. And over here I've got set up sort of a double boiler. So this is just a pot on a hot plate, but it has this internal chamber here. If I take this all the way out, you can see it's just kind of a canister with a handle. And so when I put our metal sample in there, I can heat it up to near the boiling point of water, but without getting water on it. And that's pretty critical for this because we don't want to have hot water in the calorimeter that we're not accounting for. So for this first experiment, I'm going to kind of go through the steps of recording everything, and rather than just watching straight through, what you may want to do is pause it when you need to write down the measurements or to calculate something, and I would recommend that you work through the video that way, just pausing it as you need to and following along each of the steps. So to start with, our initial situation that you want to draw a picture of is we're going to have the calorimeter with a known mass of water in it, MW, at temperature TW, and then we're going to have the sample. This is going to be coming out of the heater, so we'll have a known mass, MS, and it'll be at a high temperature TS, and that's basically our initial situation, right? We're ready to put our hot metal sample into the water. And then once we do that, we'll wait some time for them to come into thermal equilibrium, and then we'll have the mass of the water and the mass of the sample will both be at the same final temperature TF. And so that's what you want to draw for our initial and final situations here now. So I would say probably want to pause the video right now, draw your pictures for number one, and then figure out the equations for the heat loss of the sample and the heat gain of the water, and finally the specific heat of the substance, and take a minute to set up your Google Sheet to do the calculation while I get the sample heating up. All right, so here's our metal sample on the balance. You can see the mass down there is 65.65 grams, and I'm going to go ahead and heat it up so that we can run our experiment. Okay, so we've got our calorimeter here. I've tared the balance when the cup was empty, and I've added about 100 grams of slightly cooled water, so the mass of water in there is 100.24 grams. Okay, so we've got our calorimeter set up here, and if we take a look at the Capstone acquisition program, you can see my sample's getting nice and hot. It's at about 85 C. The water here is at 17.7, just below room temperature. And I'm going to go ahead and move the sample over into the calorimeter now. So we won't use the values on screen for the initial temperatures just yet. I want to wait and see what the sample is at right when I put it in. We'll get a value from the graph. Okay. So now you can see the temperature of the sample plummets, temperature of the water is going up. They're converging to meet in the middle. And it looks like this shoulder here is probably when I took it out. Took it out of the calorimeter. I would say right here is right around that corner is probably where we hit the water. And we'll take a closer look at the water temperature and see if that makes sense. You can see there's a little bit of noise there, but the water is starting to heat up right around there, so that looks pretty good to me for our starting point. Let's see if I can get the cursor right there. And looks like our temperatures are nearly converged here. Actually, the water is a little warmer than the sample right now due to stuff moving around. Let's zoom in over here. We could probably take that crossing as the final temperature. Let's take a look and see what they do for just a minute. Yeah, maybe we could take sort of the average of these two temperatures. It looks like they're pretty close. We mix. Okay, I'm going to stop recording. Yeah, it's probably reasonable to actually take where they cross here as the final temperature. So we zoom out and look at everything. Our sample temperature was 84.2, water temperature was 17.7, and then the final temperature of both was about 21.3.